Okay, so in week 11, we are moving on to topic 5, which is modular numbers and magic squares. Okay, so for this week, we are going to do modular numbers, and next week, we are doing magic squares. Both these topics come under topic 5. Okay, so today, our objectives for this class is at the end of this class, you'll be able to understand and describe modular numbers up to mod 12. Describe modular congruence. Determine the sum, difference, and product involving modular numbers. That means we're going to do modular arithmetic involving addition, subtraction, and multiplication. And we're also going to solve non-routine problems involving modular numbers. Okay? So the first thing that we want to look at is what is modular numbers? Okay, modular numbers. Okay, supposing we had two numbers A and B, okay, and we wanted to divide A with B, okay. We divided A divided by B, and we get an answer here with a remainder. Say we have a remainder here, okay. So this A here is called the dividend, okay. B is the divisor. What's our Q? Quotient. Q is the answer. Q is the answer is the quotient, and R is the remainder. Okay, R is the remainder. Okay, so this is normal division. When you do normal division, when you divide two numbers, you get the answer, and sometimes you get a remainder, and this is what it all represents. But sometimes we are only interested in the remainder. We want to know what is the remainder. So when we want to know the remainder, we cannot write here A divided by B is equals to R. Okay, because this is wrong. So we can't write like this. So we must find another way to write this so that we can look only at the remainder. Okay, so there's a special way of writing this, and this is how we write it. A mod B is equals to R. A modulo B. A mod B or A modulo B, okay? A modulo B is equal to R. A mod B is equal to R, or A modulo B is equal to R. B is the mod or the modulo here, okay? So for example, we have 13 divided by 5. How much is 13 divided by 5?
2.6.
2 remainder. Can you give me in this form?
2 remainder 6.
Again?
Remainder 6.
Are you sure? 5 times 2 is 10. Okay, let's do long division.
No?
13 divided by 5. 2. 5 times 2, 10.
3.
Minus. Okay.
Sorry,
2
madam.
remainder is okay. 2 remainder 3. Okay. So if we only want to look at the remainder alone, we don't care what the answer is. We are interested only in the remainder. So we can write this as 13. We are dividing with what number? 5. The mode is the number that you divide with. 13 mod 5 is equals to 3. So when you see something like this, you know that 13 divided by 5 gives you a remainder of 3. That is what it means. Okay. So a number x mod n is the equivalent of asking for the remainder of x when divided by n. Okay. So if I write here 14 mod 8, what should I write here? What does this mean? It means 14 divided by 8 is equal to the remainder. What is the remainder? 14 divided by 8, the remainder is how many times? How many 8s do we have in 14? If you're not sure, you do long division. 14 divided by 8. 1, 8. What do you have here? 6. 8 cannot go into 6. So this is the remainder. So the remainder here is 6. So 14 mod 8 is equal to 6. This means 14 divided by 8 has a remainder of 6. Can you understand that? You must be very clear about this, okay? Yes?
Okay,
11 mod 2. Give me the answer quickly.
1.
Okay, 11 mod 2, 1. 10 mod 6,
4.
8 mod 4.
0.
0, yes, correct. 8 mod 4 is 0. Okay, so this is what you mean by modular numbers. When we write, you see this one's equal to, this sign is equals. So 11 mod 2, that means 11 divided by 2, the remainder is 1. Okay, modular numbers are sometimes associated with clock. Okay, sometimes they are known as clock arithmetic. Okay, because we use the clock to show the modular, to visualize the modular numbers. Okay, you look at this clock face here. How many divisions are there? How many divisions are there in this clock face? How many sections? One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 divisions, right? 12 sections. So therefore, the clock face, our normal clock face, has a mode of 12. Mode 12. Okay? So when, supposing, okay, say the time now is 11 o'clock. What is the time in 4 hours time? What will the time be in 4 hours time? In 4 hours. What will the time be in 4 hours?
443.
3 o'clock? Yes, now it's 11 o'clock, right? So in 4 hours, so we're going to plus 4, right? Is equals to 3 o'clock. Correct?
Yes.
Correct? Yes, 3 o'clock. But is this correct, what I've written here? We cannot write like this. We know that this is not the same, right? Because all this while we learn addition, we don't write like this. We know this is wrong, right? So we need another way to show that 11 is 3. So we can write 11 is congruent to 3 mod 12. Sorry, not 11. 15. 15. 15 is congruent to 3 because from 11, this is 12, 13, 14, 15. So 15 is congruent to 3 mod 12. That means 15, when you divide by 12, you get 3. Okay, the remainder is 3. And 3 divided by 12 is also 3. In a clock phase, this is, normally this one here, we will write it as, when you do modular arithmetic, we will write this as 0. So this is mod 12. Mod 12 means we have 12 divisions. After 11 is 0. This is actually 12, but we write it 0. So this is 1 mod 12, 2 mod 12, 3 mod 12, 4 mod 12, 5 mod 12, and so on. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, 13. After that, when we continue, it becomes 13. So 13 is actually congruent to 1 mod 12. Okay, 13 is congruent to 1 mod 12. Okay, so when we start from here and we move all around here and we come back to here, it's 13, right? This is 13. and we come here, it is 14. Next cycle, 14. 14 is congruent to 2 mod 12. Okay, 2 mod 12. Okay, so 14 is congruent to 2 mod 12. The next number here is 15. 15 is congruent to 3 mod 12. After 15 is 16. 16 is congruent to 4 mod 12. So after 16, say we come back to this round here. What is this number here? We can reach 24, right? We have gone 2 circles, so this is 24. So what is 24? 24 is 0 mod 12. After 24 is 25. 25 is back to 1 mod 12. And then 26. 26 is 2 mod 12. Okay, so that is why 1, 13, 25, they all are at the same place in time. Okay, 2, 14, 26, these are all in the same place of time. Okay, so this is the other way of writing or visualizing clock arithmetic. When you write like this, it means that, it also means when we take a number like this and we write like this, it also means 14 divided by 12 gives you a remainder of 2. Okay, that is why it is 2 here. Okay, that's why we use 2 here. Okay. Okay, let's look at this one here. 13 divided by 5. 13 divided by 5. So we can represent this on a clock face like this. Okay, on a clock face like this. Okay, if divided by 5, it means that the mode is 5. Mode is 5. 5, so we start with 0, 1, 2, 3, 4. And this is 5. Okay, so we only have until 4. If it's mode 5, we have until 4. 13 divided by 5. This is a positive number, so we are going to move clockwise. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So where did we stop here? We stopped at 3. Okay, that's why 13 mod 5 has a remainder of 3. Okay, or 13 can also be written as 3 mod 5. 13 is congruent to 3 mod 5. Okay, confused? Any questions? Okay, I'm going to go through it again. Okay, say mode 5. Okay, we have a number here, mode 5. Okay, okay, never mind, mode 5. So 0, 1, 2, 3, 4. Okay, so this is 1 mode 5, 2 mode 5, 3 mode 5, 4 mode 5, and so on. Okay, so if I have a number 6 mode 5 on this clock face, if I want to know what is 6 mode 5, okay, what is 6 mode 5, so I can move from here, starting from 0, 1, 2, 3, 4, 5, 6. So what is the answer here? 1. So 6 mode 5 is 1. What is 9 mode 5? 9 mode 5 will be starting from here, 1, 2, 3, 4, 5, 6, 7, 8, 9. I stop here. So 9 mod 5 is 4.
Oh,
Okay. If I want to know what is negative 4 mod 5, how do I do that? If negative numbers, use tab anti-clockwise. That means you move anti-clockwise, negative 4. The number of steps is still 4. Okay, so from here, okay, from here, we are going to 4. Okay, 1, 2, 3, 4. So where did we stop? At 1. So this is equals to 1. Okay, 6 mod 5. You know that 6 is equals to 1 times 5 plus 1. So there's one multiple of 6 mod 5 means divided by 5. Huh? So there's one multiple of 5 plus 1. This is the remainder. So this is 1. 9 mod 5. That means now how many multiples of 5 are there in 9? 2 will be 10. So this is 9. So it's 1 times 5 plus 4. This is 9. 1 plus 1 times 5 plus 4 is 9. So there's one multiple of 5 and a remainder of 4 inside 9. So this is the remainder for 4. For this number, negative number, okay? So negative 4 is equals to, we can write here, we start with 1, negative 1. So negative 1 times 5 is negative 5. Negative 5, but this is negative 4. So we must plus 1. Negative 5 plus 1 will give you negative 4. So the remainder is 1. Okay? We'll do one more. Okay? What is negative? Okay, we do another mode. Okay? Okay, let's do another mode. Let's say we do mode 7. Okay. So mode 7, the numbers inside here will be 0, 1, 2, 3, 4, 5, 6, because this is 7. 0 is 7 also, okay? So we only write until 6, mode 7. So what is 8 mode 7? So it's a positive number. So go clockwise. 1, 2, 3, 4, 5, 6, 7, 8. Where did we stop? At 1. So the remainder is 1. Okay. What is 11 mode 7? 11 mode 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Where did we stop? At number 4. So this is 4. What is negative 9 mode 7? So this is negative 9, right? Negative 9 means move anti-clockwise. 9 steps, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9. So where did we stop? 5. Okay, so we have used a clock face. We use the clock face to find the remainders for these numbers. Okay, so now let's do by calculation method. Okay, 8 mod 7, that means 8 divided by 7. We know that 8 is also equals to 1 times 7 plus 1. This is the remainder. This is the remainder. 11 is equals to 1 times 7. Why we use 7? Because the mode is 7. Why 7 here? Because the mode is 7. Okay. 1 times 7 plus the remainder is 4. So the remainder is 4. Remainder is 4. Negative 9. Negative 9 is equals to negative 1 times 7. Okay. Negative 1 times 7 is negative 7, right? If this number is smaller than this, then we can't use negative 1. We have to go 1 up, negative 2. when we times this number, 2 times 7, it must be greater than this. Okay. So when we use negative 2 here, this is negative 2 times 4 is negative 14. So negative 14 plus what will give you negative 9? Negative 14 plus 5, because we want the remainder to be positive. If we use this negative 1 times 7, then this will be a negative 2. So we don't want a negative remainder, okay? So we want the remainder to be positive. So just remember, if there's a negative, this number here, the value of the positive digits must be greater than this, okay? So negative 2 times 7, negative 14 plus 5 is negative 9. So this 5 is the remainder. This is the remainder. This is how you find the remainder. If the number is small, you can use a clock face and you can draw it. But if the number is a bit big, then it's a bit difficult for you to use the clock face and draw it, okay? Okay, let's practice one, okay? 8 mod 4. What is the answer? If you use calculation, you know that 8 mod 4, 8 is equals to 2 times 4, and there's no remainder. So this is 0. If you use a clock face, this is mod 4. Mod 4 means you must draw 1, 2,
3, 4, 3.
3. And then 8 mod 4. So 1, 2, 3, 4, 5, 6, 7, 8. You end up in 0. So it's 0. Okay? One more. Okay? Negative 5 mod 3. Okay, let's draw first. Negative 5 mod 3. 3 mod 3. So how many numbers here? 0,
1, 2.
0, 1, 2. Negative 5 move anti-clockwise. 5. Okay? 1, 2, 3, 4, 5. So this end in 1. The answer is 1. So if we use calculation method, we know that negative 5 is equals to, what do we write here? Negative, so we also write negative. Negative what? What do we write here?
2.
2, yes, very good. 2, because we want this 2 times 3, 6 is bigger than 5. We want it to be bigger than this, okay? So this is negative 6. Negative 6 plus 1 will give us negative 5. So the remainder is 1. Okay, can you understand so far?
Yes, madam.
Everybody, anybody has a question?
No, madam.
For now, no, madam.
Okay, for now, no, huh? Okay, but I've got a few questions for you all. So you tell me the answer, okay? Okay, you give me the answers quick, fast, okay? Nine mod 6,
3.
good. 29 mod 3,
1.
no. That means 29 divided by 3.
2.
Yes, 2. 9 times 3 is 27. So the remainder is 2, okay? Okay, how about this one?
One.
Are you sure? Which method are you using?
3.
3? Okay, the answer is 3. Okay. Just in case, just for those who are not very sure yet. So negative 29 is equals to, we want to know how many multiples of 4. Why 4? Because it's mod 4. So how many multiples of 4? So 29, the nearest will be 8. We know this is 7 times 4 is 28. Yeah? We can't write 7 here because 7 times 4 is 28 is less than 29. So we want to go a bit higher. So it's 8. 8 times 4 is 32. If this number is negative, then put a negative here. 8 times 4 is 32. So negative 32 plus 4 will give you negative 29. So the remainder here is, sorry, plus 3. Yeah? Plus 3. So the remainder here is 3. Okay, if you're still not sure how to do that, then you draw mod 4, 0, 1, 2, 3, mod 4, negative 29, go anti-clockwise. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So the answer is 3. Answer is 3. Okay. So for a big number like this, better to work it out like this. Okay. Okay, one more. Negative 49 mod 5. 1, yes. 14 mod 2.
0.
0, yes. 4 mod 9.
1.
1.
What does this mean? I said
4.
that this, remember I told you this means 4 divided by 9 and the remainder. What is the remainder when 4 is divided by 9?
0.
Okay. Yes. Is it 0? No. Okay, let's do long division first. 4 divided by 9. 0, right? So remainder is 4. Okay? Or if we draw the clock face, mod 9, right? So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, correct? So we want 4. So 1, 2, 3, 4. Okay? 4 divided by 9 is 0, 4. 5 divided by 9 is 5. 6 divided by 9 is 6. 7 divided by 9, 7. 8 divided by 9 is 8. 9 divided by 9, 0. Okay? Remember this, huh? So this is 4. One more last question. 5 mod 7 is equals to
5.
yes, 5. Okay, so this is the basic. You have to understand this before you go on. Okay, so everybody clear about this? Yes, huh? Okay, so let's move on to the next subtopic. Huh? So we're going to look at what is congruence. Huh? Congruence. Okay, congruence. Okay, so if you're given something like this, okay, it means that A is congruent to B modular N. This symbol here means congruent. Okay. Okay, this symbol means congruent. This is equal. They are not the same. Okay, this is congruent and this is equal. Congruent means they are in the same category. They are in the same class because they have similar characteristics. Okay, this means they are exactly the same, equals to. Okay. A, how do we read this? A congruent B modular N, or A is congruent to B modulo N, or B mod N. Okay, that is how we read this. Okay, what does it mean? It means that A mod B has the same remainder as B mod N. Okay, A is congruent to B mod N. This means that A mod N, by dividing by N, A mod N has a remainder that is same as B mod N. Okay, these two remainders are the same. That is why A is congruent to B mod N. Okay, so two integers A and B are said to be congruent modulo N if they have the same remainder upon division by N. Okay, so if I give you an example here, 52 is congruent to 24 mod 7. Is this statement true or false? How do we know if this statement is true or false? We find the remainder. So we determine 52 mod 7. How much is 52 mod 7? 52 divided by 7, what is the remainder? 7 times 8 is 56. More than this, 7 times 7 is 49. So what is the remainder? 52 divided by 7. Yes, correct. 3. Yeah? And 24 mod 7. What is the remainder? 7 times 3 is 21. That's the nearest. So the remainder is 3. So because both the remainders are the same, therefore this is true. Okay. Therefore 52 is congruent to 24 modular 7. Okay. Okay, one more. 36 is congruent to 10 mod 13. Is this true? Okay. 36 mod 13. How much is this?
Ten.
13 times 2 is 23. 13 times 3 is 30. 13 times 3 is 39. So 13 times 2 is 26. 26 and 36 is 10. So what is 10 modular 13? 10 modular 13? 10 divided by 13 is 10, right? And if this number is less, then it's that number. That means it's 10 divided by 13 is 0. So it's 0 is 10. Remainder is 10. Okay. So both the remainders are the same. Therefore, this is true. It's correct. Okay. There is another way of determining whether this is true or not. If this is correct or not. If it's true, we take the difference. This is A and this is B, right? So this is A and this is B. We take the difference A minus B. Okay. So for this, what is A minus B? 52 minus 24 is equals to, anybody? What is 52 minus 24? It's 28, right? 20, 30, 40, 52. Okay. So this is 28. And you see, is 28 a multiple of 7? 28 is 4 times 7. Okay. Because we're doing mod 7. Okay. Is it a multiple of 7? Yes. If it's yes, then this is true. Okay. So there are two ways of checking whether this is congruent or not. First method, you find the remainder for each number. Find the remainder for each number when you divide by the given mode. Okay, if it's the same, then it's true. Second way is find the difference between 52 and 24. If the resulting number is a multiple of the mode, then it is true. Okay, so this number we have checked, they are both, the remainders are the same, so we know it's true. If this is the first method, second method, we find the difference. 36 minus A minus B, 36 minus 10 is 26, and we know that 26 is 2 times 13. Therefore, 26 is a multiple of the mode, so this is true. Can you understand that? Yes?
Yes.
So in other words, this also means 36 is congruent to 10 modular 13 also means that 36 mod 13 is equal to 10 mod 13. This remainder is 10. This remainder is 10. Okay. So this one, 52 is congruent to 24 mod 7. In other words, it means that 52 mod 7 is equal to 24 mod 7. Okay. Okay, so far congruence okay?
Okay, madam.
Okay. Okay, let's look at. Okay, if I give you a number like this, say x is equals to 11 mod 8. X can be any number. Can you suggest one number for me for x? X is 11 mod 8. That means this number here, when divided by 8, has the same remainder as 11 divided by 8. What is 11 mod 8?
3.
3, correct. So what can x be? Eight, yeah? 8 plus 2 is 11. We have here 11. So 8 times 2 is 16. 16 and 3 more. Remember 3, right? 3 more is what? 19. Can we have 19? 19. 19 divided by 8 is, remainder is 3. So 19 is correct, right? So what other numbers can x possibly be? What is 8 times 3? 24. 24 plus 3 more is 27 because the remainder of 3. Can it be 27? What else can it be?
35.
35, correct. What else?
45. 40. 43.
Correct, 43. How about 3? Can x be 3 or not?
Yes. Yes.
Yes, it can also be 3, okay? Okay, so if you understand this, then you understand, okay? Okay, so